Hello and welcome to today's lecture on clipping and clamping circuits. I am MD Asaduzzaman Niloy will be conducting the lecture in it. So let us first look at our first circuit, which is clipping circuits. A clipping circuit or a clipper is a type of circuit used to prevent a signal from exceeding a predetermined reference voltage level without distorting the remaining part of the waveform. So by definition we can understand that a clipper is a circuit which actually clips the input waveform like a scissor and prohibits the input waveform or the output from exceeding a predetermined reference voltage, and in the process it does not allow the distorting of waveforms. So for example, if we look at a simple clipping circuit or clipper, there is a diode and a resistor, and for input we will use an AC source. AC source means it will input the sinusoidal signal which actually oscillates at a certain frequency. So the AC source is connected with the diode and diode is connected with the resistor or load, and across the load we will actually get the output voltage. So now what happens is like if we give a sinusoidal AC input in the input of the circuit, there will be a positive half cycle and a negative half cycle in the input. So as it is obviously as it is a sinusoidal input, so at positive half cycle the polarity of the input will be like this, and the positive side will be connected to the p type of the diode and negative side will be connected to the n type semiconductor of the diode. So it means that the diode will be forward bias obviously, and at the forward bias diode acts like a conductor, and the current will flow through the resistor easily. And at negative half cycle of this input, the input polarity will be alternate to the what we have seen in the previous diagram, that it was positive was connected to the p type, and in this circuit the negative is connected to the p type, and positive terminal of the voltage source is connected to the n type. It actually oscillates, the AC signal is actually oscillates the polarity of the input and output terminal. So in this case the negative half cycle, the negative terminal of the input source is connected to the p type semiconductor of the diode. So it means that the diode will be reverse bias, and the current will not flow through the resistor. So for a sinusoidal input voltage, the we will get output voltage at only positive cycle of the input, because at the positive side of the input the diode is forward bias, and at negative half cycle of the inputs the diode is reverse bias. So which means we will only get current through the resistor at positive half cycle of the input, and we will get voltage across the resistor at only positive half cycle of the input. Now if we see the simulation video, we can see that there is a input sinusoidal waveform which oscillates between positive and negative, and at the output, like we have seen or we have said before, that at the output the output is found at only at the positive half cycle of the input, and at negative half cycle of the input there is no output and it is zero. So we are getting output at positive half cycle of the input, and which is why this circuit is called a negative clipper, because it clips or scissors the negative half cycle of the input. So what if the diode is reversed? The If the diode is reversed, it will be clipping the positive half cycle of the input and act as a positive clipper circuit. Like you can see in the simulation video, we have a input at the upper graph and output at the lower graph. So the output across the resistor is only the negative half cycle of the input, and this circuit where diode is reverse bias, it is called the a positive clipper, because it clips the positive of the input. Now we can also add the DC voltage source, a DC voltage source in anywhere of the circuit or clipper circuits. This will give us more power or further ability to clip an input. For example, if we see this circuit where there is two diode and two DC sources, so for positive and negative half cycle of the input, we will get a clipped version of the output or input in the output. So here some portion of the positive half cycle is clipped and some portion of the negative half cycle is clipped due to the DC voltage source. So in this way we can design different clipper circuits where DC voltage source can exist or cannot exist, but we will either clip the some portion of positive half cycle or some portion of negative half cycle of the input. So I hope clipper circuits are understandable. because clipper circuit actually, if we rerun the definition, clipper circuit actually clips a portion of the input. Now for clamper circuit or clamper is a type of circuit that is used to move a signal up and down about the reference level without changing the shape of the applied signal. Now in case of clamper circuits, they actually moves the input in up and down about a reference level without changing the shape of the signal. But in clipper we saw that it clips the signal, but clamper actually clamps or moves up and down a signal. For example, if we see a clamper circuit, there is a capacitor and diode and resistor are parallel to each other. So in this case, we actually apply AC square source. So when the input is at positive half cycle, input voltage polarity is like this, and for this polarity, the capacitor gets charged and current flows through the resistor, because the diode current flows through the diode because the diode is at forward bias condition, and diode becomes uh, or acts like a conductor. And as if there is a conductor, the current will flow only through the diode, not the resistor. So in this case, because there is no current flowing through the resistor and the diode acts like a conductor, obviously there is no voltage drop across the conductor. So if we measure the voltage across the diode or the resistor, both of them are parallelly, we will get zero voltage. But there is a trick to it. We can see that the capacitor gets charged. So the capacitor gets charged up to a voltage where V input is applied. We will see the simulation next. When the input is a negative half cycle, input voltage polarity is like this, alternate to the previous diagram. And in this case, there, as the diode is reverse bias, there is no current flowing through the diode, only current will be flowing through the resistor, and the capacitor will get discharged. Previously the previous positive half cycle, the capacitor gets charged. In this case, capacitor gets discharged. So after applying KVL, we will get that the V output will be equal to V input plus Vc. So if we look at a simulated example, we can see that for the input square wave shape, there is a positive half cycle, there is a negative half cycle. But in the output, at the negative half cycle, we will get at the output, for the positive half cycle of the input, we will get only zero voltage, because the diode acts like a conductor. And at the negative half cycle of the input, we will get Vi plus Vc, which means there is a greater than the input voltage. So there is a increment in the input voltage at the output, and Vi plus Vc. So we can see that the signal is clamped, the input signal is clamped at the output. So thank you. This will be a short example of clipper and clamper circuit.